Today's lesson is about counting problems and permutations. You will be able to determine the number of ways of compound events may occur, find the total number of permutations of a set of n objects, evaluate factorial notation, find the number of permutations of n objects taken R at the time without replacement. Problems that are concerned with the number of ways a set of objects can be arranged, combined, or chosen, or the number of ways a succession of events can occur are called combinatorics problems. In problems where we consider combinations of items or successions of events, each of the results are called outcomes. An event is the succession of all outcomes. If an event is composed of more than one outcomes, we'll call it a compound event. The fundamental counting principle. In a compound event in which the first event may occur in n1 number of different ways, the second event occurs in n2 number of different ways, and so on, and the kth event occurs in nk number of different ways, the total number of ways the compounded event may occur is n1 times n2 times n3 and so on times nk. Now let's look at it how it works on this problem. In how many ways can a person dress up if they have 4 different shirts, white, blue, green, and red, 2 pairs of pants, jeans and dress pants, and 3 pairs of shoes, tennis shoes, leather shoes, and sandals. So I'm going to first make a tree diagram to show you how the fundamental counting principle works. So the first thing I'm going to do is I'm going to say we have a white shirt, a blue shirt, a green shirt, and a red shirt. We can wear each one of them with 2 pairs of pants, jeans or dress pants. So we have jeans or dress pants, or jeans or dress pants, jeans or dress pants, and jeans or dress pants. And each one of them we can wear with 3 types of shoes: tennis shoes, leather shoes, or sandals. So we have tennis shoes, leather shoes, or sandals. And again, tennis shoes, leather shoes, or sandals. Tennis, leather, or sandal. Tennis shoes, leather shoes, and sandals. And so on. So I'm not going to write the letters every time. So if now I take the last strands and I count them 1, 2, 3, 6, 9, 12, 15, 18, 21, and 24. So I could have this event occur in 24 different ways. And if I want to use the fundamental counting principle, the first thing I would say that the first event, which is n1 event, it could be the number of types of shirts. So we have 4 types of shirts. We multiply this by the second event, which is our types of pants. So we are going to have 2 different types of pants. And then lastly, we are going to multiply this by the how many types of shoes we have, which is 3. So 4 times 2 is 8, times 3 is 24. So that is how this event can occur in 24 different ways. A permutation of a set of n objects is an ordered arrangement of the objects. The total number of permutations of a set of n objects is given by the permutation of n objects, n taken at the time, n times n minus 1 times n minus 2 and times so on, and the last 3 numbers are times 3 times 2 times 1. So let's look at some of these examples. The first one is the permutation of one object, 1 taken at the time. So this would give me the permutation of one object, one taken at the time, is 1. The next one here is the permutation of 8 objects, 8 taken at the time, will be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And if we find the product of these numbers, we are going to end up having 40,320. So on this last problem, we have the permutation of 5 objects, 5 taken at the time. So 5 times, 4 times, 3 times, 2 times 1. And if we multiply everything together, we get 120. In the next problem, it says, in how many different ways can Annie, Bob, Carmen, and Della be arranged in a line? So we have a total of 1, 2, 3, 4 students. So if I want to make a decision chart, which is another way of showing how I can arrange these students, for my first slot, for my first choice, I can choose out of 4 students. For my second choice, I can choose out of 3 students because the first student is not available anymore. For the next slot, for the third slot, I could choose out of 2 students. And for my fourth slot, I can choose only that last remaining student. So the answer here would be the permutation of 4 students, 4 taken at the time. And so if I evaluate it, I get 4 times 3 times 2 times 1, which would be 24 different arrangements. This next problem, in how many ways can 6 circus elephants be arranged in a line, is very similar to the previous one. I can say that I want the permutation of 6 elephants, 6 taken at the time. So that will be 6 times, 5 times, 4 times, 3 times, 2 times 1. And if I multiply everything together, I will get 720 different ways. There is another notation, which is the factorial notation. We represent it by an exclamation mark. So n factorial is the product of n times n minus 1 times n minus 2 times all the way to 3 times 2 times 1. So basically we can say that n factorial is the same as the permutation of n objects, n taken at the time. So if I'm going to look at some of my examples, for example 5 factorial, this will expand to 5 times, 4 times, 3 times, 2 times 1, and 5 factorial in a final answer is 120. In question number 7, it's asking us to rewrite 12 factorial with a factor of 10 factorial. So 12 factorial will be 12 times 11 times 10 factorial, because 10 factorial represents the numbers decreasing by 1 from 10 to 1.